All right, hello folks. We have full room again. Clearly, CI/CD is a popular topic. So I'm curious, how many of you have figured out your, deployment story, and especially things like config generation, config templating, any of that stuff? Right. And how many of you are really looking for a solution in that space that any current tooling doesn't cover? All right, interesting. Well, that's really great. I hope you will get some useful information in the coming talk from Rohan Singh, who is an infrastructure engineer at Hustle, and he's going to talk about using Kubernetes with Basil and Helm, actually. And yeah, well, I mean, over to Rohan.
Thanks. Morning. So yeah, my name is Rohan, and I'll be speaking with you about how you can use Basil, which is Google's multi-platform build tool, to manage configuration, deploy things to Kube clusters, and also try to get some Helm in there. At least that's what my session abstract says. But in all seriousness, a lot of the fun stuff about using Basil with Kube has been covered fairly well in some sessions over the past couple of days. In fact, let me ask, how many folks in the room are familiar with Basil at all? OK, awesome. Well, I figured we could change it up a bit. For those of you who haven't heard of Basil or seen anything about it at KubeCon yet, no worries. I'm still going to cover the basics. But I also want to tell you a story about trying to wrangle configuration, trying to wrangle code while introducing Kube to a new organization. Story of what went well, but also a story of what all perhaps didn't go so well. Like a lot of stories, this one has a prologue. Let me just quickly tell you about myself and how I ended up becoming an infra engineer. I originally started to get into the infra and container space back in 2013, working on Spotify's homegrown container framework, Helios. As you might have heard at some point, we completed and released this agent-based orchestration platform written in Java literally one day before another somewhat popular project, which at the time was also an agent-based container orchestration platform written in Java, known as Kubernetes. Maybe you've heard of it. So I worked on Helios for a while, and it actually went pretty well for a project that I guess was almost technically obsolete the day after it was released. But I also started kicking the tires on Kube because I knew it was probably a future direction of things. Soon after, though, I spent a while working at a place that doesn't really use Kube a lot. It's a small social networking startup, kind of like MySpace, but you can't edit CSS. After that, I found myself at Hustle, where I am today. So Hustle's main product is a text messaging tool. It's used mostly by nonprofits and political campaigns to reach donors or voters. Works pretty brilliantly because there's a person behind each text. Folks can respond, have an actual conversation one-on-one. But also more interestingly, from the infra side, Hustle's engineering team is right at an inflection point. It's grown enough where a lot of the old ways of doing things are reaching their limits, which is, I'm sure, somewhere like a position a lot of you have been in. But also we're young enough that there's space to make decisions on things without a bunch of legacy. Some of the biggest pain points I noticed right away at Hustle were around deployment and configuration management. The process for rolling out a new service was complicated. It involved committing code, also making changes in a Terraform repo. So configuration didn't really have a single source of truth. For example, the value of an environment variable might live in Terraform. but it would also simultaneously live in a container definition in AWS ECS. ECS, if you're not familiar with it, is Amazon's kind of, I don't know, Docker Compose Plus on EC2. But anyways, to roll out a new, say, value for an envar, engineer would run a tool to change the value in ECS, then go edit the same value in the Terraform repo, also kick off a job to build a Docker image, deploy it, all this stuff. Hopefully this would all be done in a correct and consistent order without any mix-ups anywhere. This system worked about as well as you'd expect, which is to say it actually works most of the time, but then it fails sometimes, and then it's a disaster. But this was an area I was familiar with, and I figured it'd be a good place to start on a project. And I also figured, hey, it's been a couple of years. I think the last time I'd checked out Kube at this point was 2016, maybe 2017. The ecosystem around Kube seems to be getting pretty mature. Let me take a look, see how it's going, and see how easy it is. Eventually, I wanted to get to a point where all the configuration for a service would live with that service's code, and then also do the same for all the configuration for all the Kube infra stuff we needed, ingress controllers, service accounts, what have you. Pretty quickly ran into an issue. At Hustle, like a lot of places, we have a few different environments: dev, pre-prod, prod, local developer workstations, potentially ephemeral environments. Each of these environments is similar, but different, slightly different config, different variables, different setups. One of the first questions I had then was, doing this greenfield, what's the best way to manage all this configuration? We weren't really tied to anything at that point, so I figured it would be really great to have something where we could take all the config files from an environment, have some sort of templating or substitution, be able to build images, generate the final config, deploy it to the cluster. Also figured that this would surely have been solved, right? So I reached out to folks I knew who were running fairly large Kube clusters in prod, and I asked, how have you solved this? And turns out it has been solved, kind of, by a bunch of tools and projects and stuff glued together. You've got things like JSONet, KSONet, JenkinsX, Scaffold, Helm, your favorite bash scripts, even Terraform. So each of these projects, in its own way, attempts to address these issues, and some are more opinionated than others. One thing that I was really drawn to, though, a project that really stood out to me, was something that isn't really specific to this problem. And again, that's Basil. Sorry, Basil. Basil is a multi-platform build system. It's based on Google's internal build tool, Blaze. So if you ask Basil people, what is it and why should I use it, they'll be quick to list off a few really big positive attributes of Basil. It's fast. It'll speed up your builds. It can build everything, every language, things you haven't even heard of. You can set up a massive remote build farm, cache everything, build your entire mono repo in like 3 seconds, be just like Google. It's going to be awesome, something like that. So after using Basil a bit at Hustle, we found that this is true, but it's like true with an asterisk. There's caveats, right? So if you remember, like my original problem here was I was really just like too lazy to write some scripts to templatize some YAML or something. But I figured, why not go down this rabbit hole for a little while and see where it leads. Honestly, for me though, the biggest, most important virtue of Basil and what made it worth adopting, even though it can have quite a learning curve, is that it's highly deterministic. Same stuff goes in, same stuff comes out. with it, you stop doing things like running Docker build and just running kubectl apply and whatever the result is. Fundamentally, Bazel is a tool where you define some inputs, just like any other build tool, and you define actions to run on those inputs, and you get outputs. For example, you take your C source, you run GCC, you get a binary, you take your config templates, you run a command, you get the realized config for an environment. But what Bazel is really good at is guaranteeing that when the inputs are the same, the outputs are the same down to the byte. So how's this different than doing old style Docker build and just working with the result? I think really, again, what stood out to me here was that the philosophy behind this tool, I think, matches the philosophy a lot of us have had about, we treat our compute as cattle, not pets. We treat our clusters as cattle, not pets. And what Bazel is allowing you to do then is treat your deployment artifacts as cattle, not pets. So instead of, say, Docker build on a code base and then getting a specific digest, and now you have to keep this image around forever and hope you never lose it, or whatever your other binaries and artifacts are, you know that as long as the code going in is the same, you get the same stuff out. So just going a little deeper into how this works with Docker images, instead of writing a Docker file, you write a Bazel build file. It says what your inputs are to the image. In this case, just a single JavaScript file, for example. And Bazel assembles a Docker image with those inputs. Since on some level, a Docker image is just a tarball of sorts, and you've told Bazel about all of the files that are supposed to go into that tarball, you don't even need to mess with Docker itself. You don't even need the Docker daemon running. And again, as long as your input is the same, the resulting image is the same, right down to the image digest. Of course, if your image consists of things other than simple files on disk, well, it gets a little more complicated, but you can still do that as well. You can use the output of a Bazel target as the input to another target. So for example, let's say you have a target that compiles some Java, builds a jar. You can just stuff that output in your image instead. Building this way is actually usually a lot faster than running Docker build. Bazel's cache is pretty good, and Bazel is good at watching the file system, knowing what's changed, that kind of stuff. At this point, though, you've got a working build and everything is looking pretty peachy. All you've got to do is actually deploy this somewhere, say to a Kube cluster. And fortunately, there's a pretty straightforward way to do that as well. The rules K8s project provides Bazel rules or logic for interacting with Kube. So you just make a new Bazel target, point it at your image target and local deployment config, and it will happily take care of applying changes to your local Kube cluster. Say you've got multiple Kube clusters. That's not really a problem either. Bazel's config language, Starlark, is basically Python. So you can just write a nice macro that spits out a target for each of your environments using a different configuration for each. And ta-da, you've now got the ability to build images, deploy them to multiple Kube clusters just by running a single command. Because again, the input here is YAML, the output is some other YAML, and that's something Bazel is good at handling. So, I mean, at this point, clearly I had motivations other than just cleaning up YAML. Instead, I was hooked on the idea that we could make our entire build and release process faster, more stable, just by defining Bazel targets and rules for it. And all the pieces we needed to make this work end to end seem to exist, so all good, right? Well, there was just basically one issue, which is that to make everything work for you, you really need to define targets for everything you want to build in your repo. You really, really just have to commit to this way of doing things and hope that the rules exist to build things in the way you want, which they probably don't totally exist. I argued, hey, you know what? Bazel is pretty much infinitely extensible. The behavior of each Bazel rule is defined in code. The Bazel core just ties everything together and runs everything that needs to run. So if there's any issues, we can just get our hands dirty, write some rules, bridge the gaps. Won't be a big deal. Well, as the Bazel docs themselves say, quote, rules are for advanced users. We expect that most people will never have to write one. They will only load and call existing rules. And honestly, yeah, rules turned out to definitely be for advanced users. While up to this point, I think I've explained Bazel at a high level, it took a fair amount of time to become familiar enough with it to be able to write rules that work like they should. Probably at this point, only a fraction of our engineering team has even written any Bazel rules themselves, even though it's something we've had to tackle to meet our needs. For example, we, at this point, had all of our build processes for our binaries and images and our K8s manifests defined using Bazel targets. So it seemed like, hey, you know what's a really good idea? Let's just try to run all of this locally. It could potentially be a good replacement for our current local dev setup, which is basically largely based on Docker Compose and duct tape. But that said, it would be nice to hide a lot of the complexity of Kube for developers who aren't working on infra, right? So one great tool I found for this was Tilt. Tilt gives you a friendly UI for what's going on with your build, your development Kube cluster, all of that. And it integrated pretty seamlessly with the normal way of building Docker images. It would even keep track of dependencies, rebuild images, do live reloads. People liked using it. And it pretty much all worked out of the box as long as you're building Docker images the normal way, which, well, we no longer are. So to take advantage of Tilt, and probably to take advantage of any similar tools in the future, we have to drop back into Starlark, the Bazel config language, and write rules that expose the parts of the Bazel graph that these tools need. Honestly, it was only a couple of days of effort in this case, and it was worth it in this case, but it's something we're gonna have to do in the future probably for other tools. Then we hit another small road bump, and that was Kotlin. Again, there are rules available for Bazel to build Kotlin, but only with support for Kotlin 1.2. Now, I've actually never written a line of Kotlin in my life, so I don't really have a horse in this race, but Kotlin 1.3 has been out since last fall, so we'd already upgraded all of our Kotlin code base, and so we were just kind of stuck. Fortunately, though, I had a colleague with some Blaze experience from Google, and with some headbanging, he was able to fork and hack rules Kotlin, get it to mostly work with Kotlin 1.3. We were able to keep moving forward. That said, most of Hustle's application code is in Node.js, and this has been a fun exercise. With Docker files, Node seems fairly straightforward, right? Like, it's just JavaScript. You put it in the container, you run Node. How hard can it be? And there's also beta Node.js rules available for Bazel, but they only cover certain scenarios. So if you're like me and you had your head kind of willfully buried in the sand regarding JavaScript for the past few years, you might be a little surprised to find that it has a complex and thriving build toolchain. So there's various flavors of JavaScript, which are transpiled to plain old ECMAScript using various transpilers. Our toolchain at Hustle includes fun tools like Babel and Flow and Mocha, which unfortunately Bazel's rules Node.js is mostly focused on plain old JavaScript and TypeScript. So again, we ended up writing our own rules to deal with things. In some cases, we were definitely blessed because we found contributions by Bazel community members. But by and large, it's been DIY on this front. It's been particularly fun to deal with when it comes to building Docker images on developer laptops. So remember how I mentioned earlier that Basil builds Docker images without Docker, just builds the binaries you need, assembles images out of tarballs. Well, let's say you build a Docker image using Basil on your MacBook. And the Docker image is for a Node.js application, or maybe a Python application. And that application is using some sort of native module. Well, guess what architecture that native module ends up being built for? It's not going to be an ELF binary. It's going to be, you've now got a Darwin binary that you're putting in your Docker image because you use Basil to build this binary on your Mac. This has proven to be a particularly tricky problem to solve. I mean, obviously one approach is, okay, everyone switch to Linux, but that hasn't been, that's not something that we were able to do overnight. So this has been pretty tricky. Workarounds aren't great yet. What we've been doing instead is using an experimental Basil feature that lets you run certain actions in a Docker sandbox. So then we build native modules in that sandbox. If you're on a MacBook, that sandbox is Docker in a Linux VM. You get a Linux binary. It all works out. But even once we have these modules built for the correct architecture, we still have to deal with the fact that they are massive. Even a simple Node.js project ends up with perhaps 100,000 files in its source directory. If you're not familiar with this problem, which I wasn't super familiar with it, you can go read about it, and it's based on a lot of old decisions. But, I mean, for most Node.js apps, this works out fine once you've actually built this giant node modules directory. For Basil, though, to be able to cache things, to meet guarantees about determinism, to know that the inputs are the same or whether the inputs have changed, it reads and calculates the hash of every single one of those files on a build, which really, it could take forever. And it's required a lot of special tooling on our end to make sure that we build the right targets and we don't just do the naive approach of, hey, build the monorepo and hope everything works. All that said, once it was all wired together, we could just run a single command, and it builds all of our binaries, builds all of the images associated with those binaries. It pulls up all of our K8s manifests. It pulls up template vars for, say, your local environment is this example, puts those in, and then deploys those to a local Kube cluster. And by using tilt, again, like we get visibility into those services. They get live updated as source files change. But unfortunately, everyone's laptop basically lit on fire because this is just, I mean, in retrospect, trying to run your whole ecosystem locally, something that works when you have maybe a handful of microservices, but Hustle was already growing to the point where we're kind of on the edge of that, and then adding additional tooling like Basil, a local cube with Minikube or Kind or MicroK8s or whatever you're using, just kind of pushed it over the edge. That said, would I do this again? Absolutely. And the main reason is because, so the local development side of this didn't work out, but we are now at a point where we have a great tool for building and deploying services to our actual clusters. So even though it has been more effort than I expected, our builds are faster, our tests are faster, and we actually do have our first pilot service where the code and config all live in one place. And Basil has also made it easier now, even though we are primarily a Node.js plus Kotlin shop, to integrate Go or Python or whatever into our build process where it's appropriate. We can just drop it in without having to make major changes. So all in all, I think this is a great tool that fits well into what a lot of us are doing. But honestly, just like Kube, it's something that you really need to understand and operate for a bit before it becomes really useful. But having skipped a slide there. But yeah, having operated it now, it's something I would do again. Also, I mentioned Helm earlier. We didn't actually end up using Helm, but if you want to use Helm with Basil, you can find this code in my slide deck and copy it. Hopefully it works. Thanks. That's all. Any questions?
Thanks very much. We have about 10 minutes for questions. See one there at the back.
Oh, hello, thank you. So what's your approach on keeping secrets or storing secrets and pushing that to the clusters?
What's our approach for secrets? That's a great question. So we originally were keeping secrets in our Terraform repo with git crypt. And that was not the greatest way to do things. Instead, what we ended up doing is, as part of the process where our YAML for Kube is generated during a Bazel run, we also run a tool that goes to, in our case, AWS parameter store, but you could go to Vault, you could go to wherever your secrets are, and injects those into Kube secrets.
I had a question actually also. Do you run a build farm with the cache and stuff? And
we have a shared build cache for our CI agents,
okay.
But we don't have a build farm or build cache for our developers.
And your CI being anything commonly used? Or?
Build kite, yeah. We're
Build
using
kite.
build kite for CI. Works well for this kind of use case.
And that runs on Kubernetes also or elsewhere?
Yes, and that also runs on Kube. Yeah, deploys itself.
Do you do any like more complicated deployments, like Canary Deployments or something like that? And do you integrate it into Basil in some way?
Sorry, do we have more complicated components doing what?
That deployments, like Canary deployments and things like that. Do you do that? And if you do you integrate it into Basil?
So do we have Canary deployments or something like that? No, we don't have Canary deployments right now. If we were to do it, yeah, I'd have to look at how to approach it. Yeah.
Hi, thanks for the talk. Do you have a way to, do you figure out how to deploy to multiple clusters? I mean, if you have multiple production clusters in different regions, how do you do deployments? What do you do if one deployment fails? Do you roll back everything? Does Bazel help you with that or no?
So I believe the question is, how do we debug multiple Kube clusters? Is that right? Or connect to multiple?
I'm specifically asking about deployments. If I want to deploy a new code to multiple production clusters living in different regions, how do you orchestrate that? What do you do if one deployment fails but other are fine? Do you roll back everything or just, firefight?
Okay. Sorry, I misheard you earlier. So how would you deploy to multiple Kube clusters using this model? And what do you do if one deployment fails or something else like that? So the way this is set up, and again, like Bazel is a rules engine, right? So it's building things and it's executing what we tell it to. The way we have it set up, when we run a single command, it deploys everything to one cluster. And then we actually have it gated before going to the next environment and the next. If you're doing like multiple clusters for, say, I don't know, cross-region or something, that's something that if you used our model where it's, one command deploys to one cluster, then you could orchestrate that or synchronize that however you want. You could run all of them. You could run one, wait, run the next, so forth.
Hi. Do you have also a CI/CD in the same way for your infrastructure deployments?
So do we have CI and CD in the same way for our infra? Yes, for parts of it. So for the parts that are in Kube, then yeah, this all gets pulled in the same way because we have in this same repo, or say like all of our Nginx, Ingress, our CI/CD server, some other, like all the other fun bits and pieces, and then those get deployed to our dev environment on a build, and then they can be deployed to the next environment and the next environment.
More questions? Okay.
Hi, thanks for the talk. You said, or you stressed that Bazel is, I mean, you focused on determinism, but if we talk about speed, compare you with your previous build system, how fast, I mean,
okay.
you improve it?
So yeah, so I think if I heard correctly, I spoke a lot about like determinism and correctness, but like how does Bazel give you more speed? So there's a few things here. I mean, like empirically, our builds are faster, our tests are faster. Why is that? One thing is that Bazel keeps a warm cache of everything it's built. So we're using BuildKite for CI. That means we run the CI agents ourselves. We can do the same with, I don't know, Jenkins or whatever, right? But running the CI agents ourselves, we have these long-running Bazel processes, and whenever there's a change that they need to build, they really only need to build whatever's changed since the last commit, in theory. In practice, we've had to do more to actually walk the entire dependency graph, which you can do because you've built a dependency graph, and figure out, hey, this commit affected these files, that could possibly affect these targets, which could possibly affect these tests, and then just build those changed things and then test only the tests that are affected.
Yeah, before I pass the mic, I had another question. So you mentioned the learning curve. So how long did it take you to get comfortable with Bazel, and just so that you show the rest of the team or anybody in your team, how long did it take them to learn the basics, and then later how long this whole project ran for, just to give a timeline? I mean, I guess that would help,
yeah,
right?
Sure. So like how long does it take to get comfortable with Bazel, and what's the timeline for something like this? So I think there's actually like two different levels, right? There's one is like, can you use the tooling? And then there's, can you build stuff around this tooling? And you can see the same thing with like Kube, right? Like, can you build stuff using Kube versus can you use kubectl? I think just being able to say, do Bazel run, Bazel build, that kind of stuff, maybe a few days for people to get familiar with like, you know, here's kind of the paradigm. To actually be able to write rules effectively and understand all of what's necessary to write something correct, that took at least a couple months of ramp up. This whole project has been going on for about 6 months now, and it's ongoing.
Okay, then why Helm? I know it's not about the build, but did you evaluate any other solution, maybe a homebrew templating?
Yeah.
Why Helm?
So why Helm? So that is a funny question, because in the end, we didn't actually end up using Helm. But at the time that I was submitting this proposal, we were. So I evaluated a bunch of things at this time, right? A lot of them you saw up here. Helm, one of the big draws for it, I think, is that there's a huge community around it, right? There's so many charts. There's this, you can install things. People have shown you how to package stuff for Kube. In the end, we moved away from it because it required, at least in Helm v2, running tiller and all this other stuff in our repo. But what we do still make use of is the ability to render Helm templates out to manifest and then apply those using our normal process.
So you moved away from Helm?
Yes, so yeah, we moved away from Helm in the end.
And you only use the template rendering part of Helm?
Yep, exactly. We only use the template rendering part.
So was it a good decision?
Was it a good decision to move away from Helm or to move to Helm?
To use it in the first place?
Well, I don't know. You know, we used it experimentally, and it seemed like it could give us a lot of speed up and productivity benefit, right? Like we can just install things. But in practice, no, I don't think that really worked out, because nothing's as simple as just Helm install and everything's going to be great in production, you know?
Okay.
Or maybe it is. I don't know. Maybe I was doing something wrong.
A few more minutes. question over here.
Can you give out some stickers?
Oh, yeah, sure. I'd be happy to give out some tilt stickers here.
All right.
If anyone wants some, come on up.
More questions? All right.
On average, like around how fast is your like build, and then also like how fast would be like the build to seeing the container running in the environment?
Okay, so on average, how fast is our build, and then how fast is like build to see a container running in the environment? So a build, so we have a mono repo, right? The build time scales with how much you've changed. If you change, say, some files in a Node.js service, we can complete CI in around 90 seconds now. If you do a couple services or something like a complicated backend, it might take up to 3 minutes. Once CI is complete, when we trigger the actual release to an environment, I don't know, like mostly it's just the overhead of telling the agent to do the thing. It takes a few seconds. I guess the biggest part is pulling down the image and the new image and running it.
All right. Perhaps last question?
All right.
Okay. Well.
Thanks, all. And
thanks very much.
some
Enjoy
stickers
lunch.
if you want.